Hello and welcome back. We are in the 6th lesson for our trigonometric review. Today we're going to be talking about applications of trig ratios, and a lot of these you already know how to do. You should have pre-printed notes, so let's get going. On this one, we're going to be talking about angle of elevation and depression. And what you need to remember is that your eyesight is horizontal, it's parallel with the ground, and you would stand at a 90-degree angle with the ground. That'll help you with forming these triangles. If you're looking upward, that is called angle of elevation. You're looking up towards something, and the angle is measured from the horizontal position to how far up you look. And they even have those transits and things like that to measure that. That's what the road crews are using. Looking downward, that's the angle of depression. So here, angle of depression, you're looking down, you're down in the mouth. That is angle of depression. So here's our basic strategy. Here we have an application of these trig ratios. A surveyor, and he's got his little transit here, is looking to the top of the cliff and wanting to know how tall it is. Using a machine that can measure angles, that's a transit, she has determined the line of sight to the top of the cliff is 30 degrees above the horizontal. So you have the angle. How high is the cliff above her eye level? So when I start out, my basic strategy is to locate the right triangle in the drawing and then label the side you seek with a variable. In this case, we labeled it h. And then relate the sides and angle using sine, cosine, or tangent. Then once we have the equation, we can just solve it. So what we're going to do here, I have h and I have 100. And I do not have the hypotenuse. So h and 130, those are related with tangent of 30 degrees. So there's our equation, and you've already done practice solving this. You multiply both sides by 100, and we'd end up with 57.753. But wait, you say, this is a special right triangle. You could also solve it with their special angle. Since it's a 30, 60, 90, that's a 1, 2, square root of 3 type triangle. So if you wanted to use your special relationship, you could, and you would end up with the same answer. You could actually get the exact answer. So if we start out with 1, 2, square root of 3, and we know that x square root of 3 is 100, then we divide both sides by the square root of 3, and you would find that 100 divided by the square root of 3 is approximately 57.753. This is the exact answer. 100 square root of 3 is the exact answer. That's the decimal. That's the approximate. All right, so let's look at this one. Here's a roller coaster, and it says, on a certain part of a roller coaster ride, the track is straight and makes an angle of 45 degrees with the horizontal. Here's the horizontal, there's that 45 degrees. So how far did the riders drop vertically while traveling 50 feet along the track? Now they have the pictures for you here. The hardest part of this section is drawing the pictures yourself, but we'll work on that together in class. So here's the vertical drop, and there's the horizontal distance that they're traveling on the track. So we start out, there's our angle, there's our leg, and then that's the hypotenuse. This is opposite and hypotenuse. So we know we're going to do the sine of 45 degrees. There's our equation, multiply both sides by 50, and you've got it. You could also use your special relationship, because you know the legs are equal, and the hypotenuse is the leg times the square root of 2. So to solve for this guy, all I'd have to do is divide by the square root of 2 to find the lengths of these legs. So that also, 50 divided by the square root of 2, if you do that on your calculator, you'll see that it's 35.36 approximately. All right, here's a roof. And why would they need this distance along the top of the roof? Well, perhaps they're wanting to know how many shingles to buy. It could save you money. You don't buy too many and you don't buy too few. So they're looking for the length along this roof for a 40-foot span. So the architect is designing a home in a town that gets a lot of rainfall. To avoid having too much standing water, the roof has a 15-degree slope, which is also called pitch when you're talking about building a roof. Assume the distance from the center of the house to the outside is 40 feet. Find the length of the roof labeled part X. So we've got an angle, we're given one side, and we're looking for the other. This one we definitely need our trig. So this is adjacent, this is to the angle, and this is the hypotenuse. So Hopefully by now you know the trig ratio that we need is cosine. So cosine of 15 degrees equals 40 over x. Now, when you're dealing with proportions, this and the x can change position. Now, the first time we did this, I said you could put a 1 under the cosine and then do the cross products. But a property of proportions is I can actually just take this cosine and swap places with the x right here. So they can just change positions. So x is the same, this equation is the same as x equals 40 divided by the cosine of 15. When we plug and chug that, we get approximately 41.41 feet. Alrighty. So last but not least, now this one actually came out of a pre-calculus book that is on the level of pre-calculus. Most of these items that I've been doing are from geometry, and we haven't even had any hit the algebra 2 level. But this problem is on your level. So here's how it's stated. It says find DC. Now you might not be able to see this, but this is a D over here. So this is DC, the distance from a cliff to the buoy out in the ocean here. So from D to the buoy, how far is that? When you see this diagram, you need to remember that these guys are parallel. Line of sight, this is the line of sight from the lighthouse, and they're looking down 16 degrees. My first thing is to label the part that I'm looking for with a variable. I'm using x. I could have used little d or something like that. I know, that's a new joke. Alrighty, I pick out the right triangle here. I can see that the right triangle is triangle ADC. I know that the part I'm looking for is this distance right here. Do I have anything else in that triangle? Well, I know the distance from A to D. How, you ask? Because they labeled from this line of sight down to the ocean is 44 meters. And they also labeled from here to here is 1 meter. So AD, using logic, has to be 43. Because 43 plus 1 would give you the total 44 meters. So I took 44 minus 1, got the height of that guy. So now then, I need an angle. I have no angles in there. There are a couple of ways that you can look at this. This is the beauty of geometry. I can use my parallel lines and alternate interior angles, or I can use the fact that angle BAD is 90 degrees. If angle BAD is 90 degrees, and I know this much of it's 16, I can find that angle CAD is 90 minus 16. So that's going to be 74. Notice if I would have done alternate interior angles and done this in the Z, this is 16 degrees, and this little angle down here by C is 16 degrees as well. Either way works. The reason I picked this one is because when I do the tangent, which I've got the two legs, x and 43, I wanted the number on the bottom. But you can use either angle and you will end up with the same answer. So if I look at this, CAD is 74. So I'm setting up my equation. 74, this is the opposite leg, this is the adjacent leg, so it's x over 43. Multiply both sides by 43, bada boom, bada bing. You get approximately 150 meters. All right, so that's how you can use right triangle trigonometry to solve problems in the world. And that's how they use it a lot of times when they triangulate position and that kind of thing. I'll see you tomorrow.